everyone, this lesson is for section 4.5, radical equations. This is a video for Algebra 2 Extended. So here's your learning target. I can solve equations containing radicals. So remember, equations have an equal sign in them. And when we solve them, we end up with an answer of x equals a value. So here's our steps for solving. Just some things you might want to highlight, underline, circle. Step 1 is isolate the radical on one side of the equation. So that means get the radical all alone. And when I say alone, I mean by itself on one side of the equal sign. Okay, so that's step 1. Get the jail, if you want to think about it that way, all alone on one side of the equal sign. And then the second step is eliminate the radical. So it says to raise each side of the equation to the power equal to the index on the radical. So what that means is a square root has an index of 2. So to undo a root with an index of 2, we raise it to the second power. So powers and roots are inverse functions, so those undo each other, and you're just left with an x. You should probably put an arrow sign here. So that's how we undo the radicals or eliminate the radicals. So I like to call this blow up the jail. And when we blow up the jail, everything that's inside comes out. Because when you have numbers or variables in jail, you can't do math on them. Okay, you can't say, oh, I'm going to minus this 1 because this 1 is in jail. So you can't do anything with whatever's in jail until you get rid of the jail or eliminate the radical. So that's step 2. Then you're going to have a regular Algebra 1 equation to solve after you get rid of the radical. And then we're going to check just to make sure we have the right solution. So this is what they're going to look like. So we're solving, so we're finding out what x is equal to. So if you think about step 1, which is get the radical all alone on one side of the equal sign. Well, here's my radical. And if you look, there's nothing on this side of the equal sign with that radical. And what I mean by nothing is there's no numbers outside of the jail. If you look ahead to this one, we'll get to this one in a minute, but here's my radical. And see that number that's hanging around outside the jail? We need to get rid of that too. So I like to say you don't want anyone hanging around outside the radical. So when we blow up the jail, they don't get hurt. So any numbers outside, we need to move them to the other side of the equal sign. But if you look at this one, the radical's already by itself. So that's step 1. Step 2 was to eliminate the radical. So the way we're going to do that is, this is a radical with a root 2. So we're going to raise it to a power of 2. Powers undo roots. And whenever we're working with equations, whatever we do to one side, we have to do to the other to keep it balanced. So what's going to happen here is power 2 undoes root 2, and what I'm left with is just the x. So think about the radical is your jail. When you blow it up, it crumbles, and you're just left with the x. So the 2, power of 2 blows up the jail, the x is left. And on the right side of the equal sign, we have 4 squared. So we're going to have x equals 16. Okay, and if we want to check this answer, we go back to our original equation, square root of x equals 4. And where there's an x, we're going to replace it with a 16. So in this equation, we're going to replace the x with a 16. And then what we're checking is this true? Is the number on the left side of the equal sign equal to the number on the right? Well, if you do a jailbreak on 16, you're going to get a 4. So 4 equals 4. Yes, that's true. So then I know 16 is the correct solution. Okay, this one looks a little different, but again, if you think about step 1, here's my radical. Is it all alone by itself on one side of the equal sign? So on this side of the equal sign, notice there's no numbers hanging around outside the jail. So then step 1, isolate the radical, is done for me. Step 2, eliminate the radical. So I'm going to raise this to a power of 2 because this is a root 2 radical. Whatever I do to one side, I have to do to both. So this is going to be power of 2 over here. So power of 2 undoes root 2, and what I'm left with is x plus 1 equals 4 squared. Or x plus 1 equals 16. Continue to get x by itself, minus 1 from both sides, x equals 15. Okay, I'm not going to check all of these because the video will be too long if I do that. Alright, now here's the first one where we have to do step 1. And there's the reason why we have to do step 1. If you look on this side of the equal sign, this 2 is hanging around outside the jail. We need to get rid of that 2 first. Now this 2, there's no operation in here, so that means when there's no operation, it's attached by multiplication. So we need to undo multiplication with division. So this is the same as 2 multiplied by the square root of x plus 1. So to undo 2 multiplied, we want to divide by 2. And then if you think of outside the jail, remember we don't do any math on the numbers in the jail. Outside the jail we have 2 divided by 2, which is just 1. So now I have this. 4 divided by 2 is 2. So now that was step 1. I have isolated the radical. Now I want to eliminate the radical. Square both sides. Second power undoes second root. X plus 1 is left equals 2 to the second power is 4. Minus 1 from both sides. X equals 3. Okay, so once you eliminate that jail, this is where you're just left with that algebra 1 equation. Alright, page 27 you should be on now. Oh, I forgot to say, this started on page 26. Okay, these are your turns. So what I want you to do is pause the video and solve these your turns. And then we will, well, I'll tell you what, you pause it, you solve them, and then I'll tell you, you should get y equals 25 there. This would be x equals 23 is what you should have gotten there. Now you should have some work in here for yours. And then the last one, you should have x equals -1. Okay, so check your work on those. Now let's look at this one. They're getting a little bit dicier already. Now I'm just going to draw a wall for my equal sign. Now if you look on this side of the wall, here's my radical. It's helpful to even put it in a box. And so what needs to go, what's hanging around outside the jail, is the 3 and the -8. So we do need to do step 1 where we isolate the radical. Now what we want to get rid of first is whatever is furthest away from the radical. So here's my radical. The 3's right next to it. The 8's a little further away. So I want to undo this -8 first. The 8 is attached to the radical by subtraction. To undo subtraction, I want to add 8 to both sides. -8 and +8 gets me 0. So on the left side, I have the 3. And the x plus 1 still in the radical. Over here, 8 plus 4 is 12. Okay, now, still, the radical is not by itself on one side of the equal sign because I have that 3. The 3, if you don't see an operation in between there, a plus or a minus, then the 3 is attached by multiplication. So to undo multiplication, I'm going to divide both sides by 3. So 3 divided by 3 is 1. On the left, I'm left with the square root of x plus 1 equals 12 divided by 3 is 4. So all of that was step 1. Okay, now step 2, eliminate the radical. Finally, I can do the second power here. Both sides. Second power undoes second root. What's left standing in the rubble is the x plus 1 equals 4 to the second power, 16. So that was step 2, eliminate the radical. Step 3, solve the equation. I want to get x by itself. Undo the plus 1 by subtracting. 1 minus 1 is 0. X equals 15. Okay, now let's check this. I'm going to do that over here. So we want to rewrite our original equation. And what we want to do is replace the x with a 15. So now this equation is going to look like this. 3 times the square root of 15 plus 1 minus 8 equals 4. And the question is everything on the left equal to what's on the right? Well, this is 15 plus 1 is 16. Minus 8 equals 4. The square root of 16, or if you do a jailbreak on that, you're going to find that that's 4. So now what I have is 3 times 4 minus 8. Once again, does that equal 4? 3 times 4 is 12. 12 minus 8, does that equal 4? Yes. So then we know 15 is a good solution. Okay, this one's very similar. So think, here's my radical. What do I need to get rid of? This minus 4 and this 2. So this 2 is attached by multiplication and it's right next to the radical. So we don't want to get rid of that first. The 4 is farther away, so we're going to get rid of the 4 first. The 4 is attached by subtraction. To undo subtraction, we're going to add 4 to both sides. So on the right side, I'm going to have 12. 8 plus 4 is 12. 4 minus 4 is 0, so the 4 is gone, and I still have this. Okay? So now I need to undo the 2 that's multiplied by the radical, because still I have the 2 hanging around outside the jail. Got rid of the 4, need to get rid of the 2. So 2 is attached by multiplication. Remember, a number right outside the radical means those are multiplied. So to undo multiplication, I want to divide both sides by 2. 2 divided by 2 is 1. Remember, I'm not going to divide that 2 into here. These numbers in this variable are protected by that jail. I cannot do math on those numbers. So I have 4x plus 8. I really have a 1 out here, but we don't need to write that. 12 divided by 2, 6. Okay, finally, this again was all step 1. Isolate the radical on one side of the equal sign. Now let's eliminate the radical. Radical with a root 2 gets raised to a power of 2. Power of 2 and radical 2 undo each other, and what I'm left with is 4x plus 8 equals, careful, 6 squared is not 12, it's 36. Continue solving for x. 8 is further away, so I'm going to minus 8 from both sides. That gets me 0. So now I have 4x equals, let's see, 36 minus 8. Cross that out, make it a 2, make that an 8. This is your old-fashioned subtraction, right? 28. Now, you can check your calculator and see if I did that right, but see how quick I did that without a calculator? Now to undo 4 times x, I want to divide. 4 divided by 4 is 1, so I'm left with x equals 28 divided by 4, x is 7. Okay, I'm not going to check this one because the video is pretty long. Okay, now these are yours also. So I want you to do these, and then what I would like you to do is to compare notes with maybe your table partner after everyone's done watching the video and see if you got these right. And then we'll check these in class tomorrow also, but definitely try these. I want to see these done in your notes. Now I want to do I think I'll do one more example in this problem. So what's happening here is, if you notice right away, I have a third root jail. So when I eliminate my radical, I'm going to raise to a power of 3. Because I need a power of 3 to blow up a third root jail. That's the only thing. Oh, what's my camera doing? Oh, I think when I put my hand under there it gets blurry. Sorry about that. That's the only thing that's different here. So here's my radical. First thing is to isolate it. So I got the 4 hanging around outside the jail and the 2. So the 2 is further away. The 4 is right next to the jail. So I want to undo the -2 first by adding 2 to both sides. That makes a 0, so that's gone. And on the right I have 12. Over here I still have 4 times the third root of 2x plus 11. Okay, now this 4 is still outside the radical. Remember, I want this all alone on this side of the equal sign. 4 is attached to the radical by multiplication, so I want to divide. To undo 4 multiplied, I want to divide by 4. 4 divided by 4 is 1, so those 1 out. And now I'm left with this. Third root, 2x plus 1 equals 12 divided by 4 is 3. So that's again all step 1. I had to do all that to get the radical isolated on one side of the equal sign. Now I'm going to blow up the jail. But this time when I blow it up, I'm going to raise both sides to the power of 3 because this is a third root jail. Over here, power of 3. Third power and third root jail undo each other, and what comes out? 2x plus 1 equals, 3 to the third is not 9. 3 to the third is 3 times 3 times 3. So that's 9 times 3. That's 27. Okay, continue solving for x. Subtract 1 from both sides. 2x equals 26. Divide by 2. X equals, that's 13. Okay? I'll do one more. Yeah, we got time. It's a long video, but we'll do this one quick. Remember, all the steps are the same. Very similar. I'm going to add 6 to both sides. 6 is further away from the radical than the 3. So that gets me 0. On the right I have 6. On the left I have 3 times the third root of 5x minus 1. So I need to also, I have this 3 hanging around outside the jail. I got rid of the 6 that was hanging around outside. Now I need to get rid of the 3. The 3 is attached by multiplication. So to undo multiplication, I want to divide both sides by 3. 3 divided by 3 is 1. So I'm left with 5x minus 1. Third root, don't forget to write that index. Otherwise you won't know what power to raise it to. 6 divided by 3 is 2. Okay, now I need to blow up my third root jail here by raising it to a third power. third power undoes third root. I'm left with 5x minus 1 equals 2 to the third, which is not 6, it's 8. I'm going to move this over here. Okay, now I'm solving for x. Undo a subtraction here. 1 minus 1 is 0. I'm left with 5x equals 9. Undo 5 times x by dividing by 5. 5 divided by 5 is 1. X equals 9 over 5. Your answer is a fraction. That's okay. Don't panic. You can leave it right there as a fraction. You could turn it into a decimal too also if you wanted, but you don't have to. Okay, so that's it. That's what I'm going to call it for this lesson. Now, I want you to try these problems, and I will quickly see if I can give you the answers to these. Okay, this one, when you solve it, you get another fraction, 12 over 9, which you could simplify that fraction and it would turn into 4/3 or 1.33 repeating. So when you solve that, that is what you should get. And this one you're going to get So you're going to get x equals -95. Okay? So try those, see if that's what you get. And I'll probably do example 6 in class tomorrow. So if you finished your turns and finished your video, what I want you to do now is to go to, we're going to skip this one. You can do this your turn also. Your turn 4 on the next page. So I will do example 6 in class. You can do your turn 4. Skip your turn D for now. Part 4D. And then on this page, you could right now do 1, 2, 3, and 4, and 5. So you should try 1 through 5, and then we will look at 6 in class tomorrow. Okay, that's it. Enjoy.